before we will see the what is meant by convolution and what will be the convolution with step, as well as the some problems based on the convolution with step. Now let's move on to the next concept, that will be the what will be the properties that will be present in the convolution. Okay, the first property with the time shifting property. So you already know how you can write the y of t. Y of t that will be equal to f of t convolved with step response, that will be the h of t. Okay, for example, if I want to write f of t minus t1 convolved with h of t minus t2, that will be equal to y of t minus t1 minus t2. Okay, this was the time shifting property. For example, if I want to write f of t plus t1 convolved with h of t plus t2, okay, that will be equal to y of t plus t1 plus t2. One for the advancing and one for the delaying we will take. Okay, this was the property for the time shifting. The next property be the time scaling property. Next property be the time scaling property. Okay, similarly you can write that will be the y of t that will be equal to f of t convolved with h of t. Now replace t with at. Replace t with at. Then y of at that will be equal to f of at convolved with h of at. Okay, this is also you can write y of at that will be equal to 1 divided by modulus of a, that will be the f of at convolved with h of at. Okay, for example, if you put a is equal to minus 1, what will happen? Put a is equal to minus 1. Okay, for example, if you put a is equal to minus 1, that will be the y of minus t that will be equal to 1 divided by modulus of minus 1, that will be the plus 1, right? That will be the f of minus t convolved with h of minus t. Okay, this formula for the time scaling, and this formula for the time reversal. Okay, generally this type of properties we are used in the problems. Next property be the time differentiation property. Time differentiation property or differentiation property or differentiation property. Okay, Here you can see, if you want to write y of t that will be equal to f of t convolved with h of t. For example, if I will do the differentiation, what will happen? That will be the d by dt of y of t that will be equal to, here also do the differentiation, right? That be the d by dt of f of t convolved with h of t. Okay, in some cases we have used this formula d by dt of y of t that will be equal to d by dt of f of t convolution with h of t. In some cases we are used r f of t convolved with d by dt of h of t. Okay, both are will be true only. For example, this was the property for the time differentiation or the differentiation property. Next we will see the what is meant by cascading property. That be the cascading property. Okay, for example, if you take this be the h1 of t, and here if you take h2 of t. Okay, for example, if you wanna combine this h1 of t and h2 of t, then it will become the cascade connection, right? So for example, if you do like this and replaced this h1 of t and h2 of t with h of t, then it's said to be the cascading property. Okay, next, if you want to write h of t, how you can write h of t that will be the h1 of t convolution with h2 of t. Okay, for example, if you take next property be the commutative property. Okay, the commutative property be the, if you want to write y of t that will be equal to f of t convolved with h of t. And here if you want to write h of t convolved with f of t is also be right. Okay, that is also be the y of t. If you want to write y of t is equal to f of t convolution with h of t, that is also be right. If you just reverse the things, y of t is equal to h of t convolved with f of t, that is also be right based on the commutative property. And next we can see next property be the invertibility property. Next property be the invertibility. Okay, for example, if you take the this be the h1 of t, so here if you get the output as y of t, here if you give the input as something, here this be the h2 of t, here you will get the some output as y of t, Here if you get the, if you give the x of t, here also if you get the x of t, then that system is said to be the invertibility, right? So here h of t, here h1 of t convolved with h2 of t, that will be equal to h of t. Okay, for example, if you want to write h1 of t convolved with h2 of t, that will be equal to delta. Okay, here system 1 be the invertible, system 1 be the invertible. So here if you take this be the system 1 and here this be the system 2, in general case that will be very easy for us. For example, if you want to apply the Laplace transform on the both sides, what will happen? If you apply the Laplace transform, t can be replaced with s, right? By applying the Laplace transform, h1 of s convolved with, for example, if I take this be the some hi of s, okay, when you apply the Laplace transform for the delta function, then it will become the 1, right? Then it will become the 1. For example, if I want to write hi of s, that will be equal to 1 divided by h1 of s. Okay, this was the invertibility for the convolution. For example, if you take next property be the associative property. Okay, if you want to write for the associative property, that will be the h1 of t convolved with h2 of t, that will be the convolved with h3 of t. Okay, how you can write this? That will be the h1 of t convolved with h2 of t convolved with h3 of t. Okay, in this way you can write the associative property. Next we will see the another property. Next property be the distributive property. Next property be the distributive property. Okay, in the distributive property, if you draw the some diagram like this, so this be the h1 of t, and here this be the h2 of t, and here this be the plus symbol, and here this be the h3 of t. Okay, how you can write this? This be the summation, right? This be the summation. Whenever it will be the plus and then circle, then that be the summation. This will be the h1 of t plus h2 of t convolution with h3 of t. Okay, now if you take h1 of t convolution with H3 of T plus H2O of T convolution with H3 of T. So now the required diagram has to be changed like this. That be the H1 of T and here convolved with, next what will be the case, that will be the H3 of T, and next here this be the H2 of T, and here that will be the convolved with H3 of T. Finally we have made the summation. Okay, this was the distributive property. Now let's see the what will happen if you apply the step. Okay, that be the step response. Okay, here if you give the input as x of t or the u of t, here if you given to the some system S1, some LTA system that be the, for example this be the system S. So here y of t be the x of t convolved with h of t. Okay, for example if you want to write the step response for the convolution, the range, the area range that will be ranges from the minus infinite to some t. Okay, so as be the some minus infinite to t h of tau into d tau. Okay, if you do the differentiation for this, what you will get, ds divided by dt, that will be equal to d by dt of integration of minus infinite to t h of tau into d tau. So here differentiation and integration will get cancelled to each other. So here ds divided by dt, that will be equal to h of t. Okay, that means here if you differentiate your system, then you will get an impulse response, right? That means whenever you will get the impulse response means that will completely characterize your system, then that is said to be the impulse response. The main theme or agenda for the convolution be that impulse response, right? We have to be study the what will happen to the entire system by means of the impulse response, by passing the impulse response. This was the some important properties based on the convolution. In the next class we will try to see some important questions based on the two different type of signals. That questions is very important for your gate examination point. Then next we will move to some important conclusion for that questions. Okay, if you really like this video, please like my video, share my video, as well as subscribe to my YouTube channel. Thank you.